take what we've learned over the last two videos and put them together to do some trig questions. So what I'm hoping you guys did was you either printed this worksheet out practicing with Trig Facts, or you copied these questions down on another piece of paper ahead of time. If you haven't done that, you should really pause me and do one of the two. So either print this out or go ahead and write the questions down on a piece of paper so you could follow along. It makes it a little bit easier. All right, so if you're still continuing on with this, I think it means you're ready to roll. So here we go. Number one said, express 15 degrees in radian measure. So this is what we did on the last homework. And to convert degrees into radians, you're going to do 15 over 1 times pi over 180. And then what we want to do is multiply it. So we get 15 pi over 180. Now the final answer will always be the reduced version of this. So I'm going to take my calculator and put in the 15 over 180. Don't put the pi in, just the 15 over the 180. Hit enter, and it reduces for us. It's 1 over 12. So that means it's going to be 1 pi over 12 radians. And you don't have to put the 1 in front of it if you don't want to. So it's pi over 12. All right, next one. Express tan 230 degrees as a function of a positive acute angle. Now this is a little different. Tan 230. Now a positive angle, that is positive, and an acute angle. Do you guys remember what that is from geometry? An acute angle is an angle smaller than 90 degrees. And if you take a look, 230 degrees is way too big. So what we're going to do is graph 230 degrees. So this is 0, 90, 180. This would be 270, right? So 230 is going to put me about here. So from here to here is 230 degrees. Now 230 degrees is bigger than 90, so it doesn't work. But this is when we use our reference angles. If you draw your triangle, right, with your right angle against the x-axis, we want to know what that little angle in there is, our reference angle. So notice this is 180. So I need to know how far past 180 did we go. So if I do 230 minus 180, it is 50 degrees. So the reference angle is 50. And we're going to use 50 because that's less than 90. So we're still going to keep the tan, so I'm going to write tan, but then I'm going to write 50 degrees after it instead. Now there's one more trick to this. You do have to keep track of A, S, T, C. See the quadrant where the triangle's drawn? That's the tangent quadrant. Since that's tangent, we're going to leave it positive, so we're all set. All right, next one, number 3. Express 160 degrees in radians. So we're going to do that just like number 1. So I'm going to do 160 over 1 times pi over 180. That makes 160 pi over 180. So again, we've got to reduce this. So I'm going to go to my calculator, do the fraction button, and put 160 over 180. Again, don't put the pi in. Hit enter. And I'm getting 8 over 9. So that means I'm going to write 8 pi over 9 radians. So that's what I would put here, 8 pi over 9. All right, next one. Express 5 pi over 9 radians to degrees. All right, so I'm going to write down 5 pi over 9 times. Now, to go the other way, we're just going to take that fraction and flip it upside down and write 180 over pi. Now the beauty of that is that the pi's cancel. So now I'm going to do 5 times 180, right? Or actually make it easier, do the fraction button, do 5 over 9, that's what's left over, times 180, and I'm getting 100 degrees. So that's 100 degrees. All right, next one. express 2 pi over 9 radians in degrees. All right, so 2 pi over 9. That means I'm going to do 180 over pi, right? The pi's cancel. So that means I'm going to do fraction button 2 over 9 is what's left over, times 180. And I get 40 degrees. Next one, express 3 pi radians in degrees. All right, so now this one isn't a fraction, so I'm going to make it look like a fraction. And I'm still going to multiply by 180 over pi. Pi's will cancel. And now if I put that in my calculator, I'm going to get 540 degrees. All right, so most of these, except for number 2, were ones like you did on last night's homework. All right, now let's look at number 7. If placed in standard position, an angle of 11 pi over 6 radians has the same terminal side as which angle? All right, this is a very fancy wording of saying how many degrees would this be and then which one is it the same as. So I'm going to take 11 pi over 6 and multiply it by 180 over pi. Okay? So the pi's cancel. Go to my calculator again, right? Make sure I get the glare off it. Fraction button. So it's 11 over, what was it, 6 times 180. And I'm getting 330 degrees. All right, so I'm getting 330. But notice none of these are 330. Are any of these the same as 330? So let's talk about that now. If I were to graph 330, this is 0, 90, 180, 270. So back around again is 360. So 330 brings me all the way to here. All right. Well, which one of these would land me in the same exact spot? So for example, negative 150. Oh, sorry guys, excuse me. Negative 150 means I'm going backwards. 0. Negative 90. Negative 180. So negative 150 puts me there. Is that the same spot as there? Nope. All right, now check this out. Negative 30. Negative 30 brings me down 30 degrees. Is that going to put me in the same spot as that one? It sure does, right? Because this is 330. This means I go backwards 30 to make 360 degrees. So the answer to number 7 is B. Okay, next one. Cos 280 is the same as which one of these? Now, check out all of these. Notice these angles are all really small. So that means we want to regraph this and see what's going on. So 280. So 0. 90. 180. So 270. So 280 is going to be about there. Okay. Now I'm going to draw a triangle. Okay. I need to know what the reference angle is in there. Well, this is almost the 360, right? So if I do 360 minus 280, if I put that in my calculator, I'm getting 80 degrees. So this little corner is 80. So that means this is going to be cos. Keep the cos, but we're going to use 80 instead, right? And then you have to do the A, S, T, C. Now, C is cosine. The triangle's in this quadrant, so that means it's going to be positive. So that means choice D is the right answer. Okay. Which expression is equivalent to sine negative 120? And notice, look at these angles again, guys. They're all small. So that means I'm going to graph negative 120. So this is 0, negative 90, negative 180. So negative 120 pulls me here. Okay. Again, I'm going to draw my right triangle in there. What would this angle be? What would its size be? Well, if this is 120 and all the way to here is 180, that means the missing angle is 60. So I'm going to keep the sine. I'm going to keep the 60. Now I just have to do AST. Now that's the T quadrant where the triangle is, but we have sine, so that means we have to put a negative out in front. Which of those choices is the same thing as negative sine 60? And that would be B. Alright, now that I've done those with you, I would love for you guys to try 10, 11, and 12 without me. So if you want to pause this video, give those 3 a try, then turn me back on and we'll see how you did. Okay, so I hope you pause me and you try these on your own. So what I'm going to do with the next one is I'm going to graph negative 140. So 0, negative 90, that's negative 180. So negative 140 puts me there. Triangle. All right, this is 140 and that's 180. That means the missing corner is 40. So I'm going to write tan and then 40. And then I'm going to write AST. Now that's the T quadrant where the triangle is. Hey, that's T for tangent. That means I'm going to leave it positive. That's tangent 40 degrees. So that should have been the answer for number 10. Now, if you want to pause me again and try number 11, if you didn't do that yet, you should. I'm going to keep going, assuming you paused me and tried this one. Negative 230. 0. Negative 90. Negative 180. So this is negative 270. So negative 230 is going to put me to here. Okay, I'm going to draw my triangle. And remember, your triangle always goes with the down to the x-axis. So I need to figure out what that guy is, my reference angle. Well, guys, if this is 230, how far past 180 did I go? So I'm going to do 230 minus 180. That's 50. So now I'm going to write sine 50. And then I'm going to do AS. Now, the triangle's in the S quadrant. That means I'm going to leave it positive. So that's sine 50 degrees. All right, next one. So again, I hope you paused me first. If not, you should be pausing me now. Freeze me so that you could try it. 200. So 0, 90, 180. So 200 is going to be about there. Draw my triangle. Again, right angle's always touching the x-axis. Okay? So I'm going to do how far past 200, right? So I don't know if you guys have noticed, I'm only ever using either 180 or 360 to find these angles. Okay, so that makes 20 degrees. All right, so I'm going to keep the sine. So I'm going to write sine 20. And then I'm going to do AST. Now this is the T quadrant. We're doing sine, so that means it has to be negative sine 20. And negative sine 20 is choice A. Now we're going to completely change things up. Take a look at number 13. These next bunch are going to use the formula that we talked about when we talked about radian measure. It says in a circle. All right, so I'm going to draw a circle. In a circle, that's a pretty good circle. Essential angle. So that means we have an angle touching the center. So I'm going to draw a wedge like that. An angle, essential angle containing 1.5 radians. So my angle is 1.5. Intercepts an arc. So that means this thing right here, which is 18 centimeters. The length of the radius is what? So I want to know what R is. All right. This requires the formula we talked about in the last video which is theta equals S over R. And I hope you guys remember that S stood for arc length and R stood for radius. And theta is always the angle in radians. All right, so to do this question, did they give us an angle? Yes, they did. It's 1.5 radians. So I'm going to do 1.5. And see how this is a fraction? So I'm going to make the angle look like a fraction. Equals the arc length. That's this guy. That's the 18 over the R. So now I've got to figure out what R is. So I'm going to cross multiply. So I go this way. So that makes 1.5 R equals 18 times 1, which is 18. I'm going to divide by 1.5 to get the R alone. So R, so I'm going to do this for that. 18 divided by 1.5, I'm getting 12. And that would be 12 centimeters, which is choice B. All right, so let's take a look at the next one. In a circle, so I draw a circle. A central angle of 2 radians. So the central angle, the angle is 2, intercepts an arc of 6. So here's the arc. That's 6 centimeters. Find the radius. All right, so we're going to use the same formula again. Theta equals S over R. Theta is always the angle. So that's going to be 2 over 1. S is the arc, which is 6. Now we're going to cross multiply. 2 times R makes 2R. 6 times 1 is 6. Divide by 2. And the radius equals 3, and that'll be centimeters. The answer is 3 centimeters. Okay. In a circle. Okay, so draw a circle. With a radius of 2.5 centimeters. So this time they've given us the radius. A central angle has a measure of 5. All right, the angle is 5 radians. What is the length of the arc, right? So you can make it either an X. I like using X's instead of S's because my S's and 5s look exactly the same. But we're still going to use theta equals S over R. Theta is my angle, which is 5. So I'm going to make it look like a fraction. Equals, I don't know the arc this time, but this time I know the radius is 2.5. Right? It's 2.5 centimeters. You can even put that in if you want. All right, let's cross multiply. 5 times 2.5 is 12.5 centimeters. And X equals X. So that's the answer, 12.5 centimeters. All right, now that I've done those, I would love for you guys to pause me and see if you can do 16, 17, and 18 without me. Okay, so I hope you guys paused me and you tried these. All right, let's try number 16. In a circle, a central angle of 3 radians, the angle's 3, intercepts an arc of 15 centimeters. Find the length of the radius, R. All right, so I'm going to do theta equals S over R. So I'm going to do 3 over 1 equals 15 centimeters over R. We cross multiply, so we get 3R equals 15 centimeters. Divide by 3. R equals 5 centimeters. Okay. Again, if you didn't do these two, pause me for a minute, try it, check yourself. All right, here we go. In a circle of radius 9. All right, let's draw a circle. And we know the radius is 9. The number of radians in a central angle that intercepts an arc of 18. So this time I'm saying the arc is 18. we want to know, this time we're trying to find the angle. So I'm doing theta equals S over R. So I don't know the angle, but the arc is 18 and the radius is 9. Well, what is 18 over 9? That would make 2 radians. It's 2 radians. And finally, the last one, in a circle whose radius is 4. All right. So the radius is 4 centimeters. What is the length in centimeters of an arc intercepted by an angle of, okay, so they're giving us the angle. The angle is 2.5. Angle is 2.5 equals x over 4 centimeters, right? So x times 1 is just x. And then we're going to do 2.5 times 4, being 10 centimeters. And that's the last answer. All right, guys. So this is us putting a lot of our different rules together. Your homework assignment is exactly the same thing. It's a different one. I called it, instead of practicing with Trig Facts, I called it applying Trig Facts. So this was our key for this worksheet. All right, so again, your homework is the same thing, just these questions all scrambled up.